Hi everybody, I'm Professor Andrew Knight. I'm a veterinary professor of animal welfare and ethics at the University of Winchester Centre for Animal Welfare. And in this presentation I want to talk about climate change and what it's doing to our planet, and particularly about the contribution of the livestock sector to that change. Now, my story here actually starts with one of the best days of my life. When I was extremely lucky in two ways. One, because I got to marry one of the best young ladies on the planet, and secondarily because we did it last year, the year before COVID-19. And I'm very grateful that we were able to have a fantastic wedding. We actually did this in Snowdonia in Wales. It's a place that we love. We go hiking very often, actually. And we asked our poor guests and friends to accompany us on a bit of an adventure in their full wedding clothing and sometimes fancy dress up to the top of Mount Snowdon, the highest mountain in Snowdonia at just over 1,000 metres high. So we struggled our way up the various ridges and the sun was shining brightly and the weather was beautiful when we began. But as we climbed, it got increasingly dicey, as you can see with the clouds coming in below us and around us. And we barely made it to the summit. We ended up losing my bride-to-be at one point in the fog, and we had to go and find her and her guests. But we eventually all managed to get reunited and assemble very briefly on the summit, which by this stage was in a raging storm with winds well above 50 miles an hour and horrendous rain showers sweeping across the summit. So we sadly nearly drowned our nevertheless very happy photographers who, like the rest of our guests, joined us the entire way on this amazing adventure. The very next day, it got up to 28 degrees Celsius in London. Now, I'm originally from Australia, and in Australia, 28 degrees is when the beaches are hardly starting to open, to be honest, because it's so cold. But of course, in the United Kingdom here, 28 degrees is a heat wave, and so the beaches were packed full of people. So these sorts of extreme weather events have been going on for a while now, especially at this time of year, around about July, August. A couple of years prior to that, Hurricane Irma actually swept across the North Atlantic. It was the strongest tropical storm ever recorded in the North Atlantic. It was one of the strongest ever to strike the US mainland. It was a Category 5 hurricane, and these are the ones that actually strip bark off trees and tend to demolish all buildings that are not heavily reinforced concrete several kilometres inland away from the coast. The winds were gusting to nearly 300 kilometres an hour inside this hurricane. Now, at one point, the pathway of this hurricane swept across the Caribbean here, and I'm particularly interested in this red circle right within the line of red dots, which represents the period of maximum wind strength. This is the Caribbean island chain. This red dot happens to be right there, which is essentially the island of St. Kitts, where I worked at one of the world's largest veterinary schools from 2013 to 2014, teaching professional and personal and practice management and surgical and clinical skills. Now, we were certainly concerned about cyclones, but perhaps even more about the semi-dormant volcano you can see rising up there on the right-hand side. This volcano was supposedly dormant, but we could occasionally smell sort of whiffs of sulfur gas as we walked around the campus. And there was still scalding hot steam issuing from certain vents inside that volcano. So we had an evacuation plan. We took health and safety very seriously, and we would practice evacuating along the coast in case the volcano ever blew on a weekly basis. You can see us there engaging in our dedicated practice because we were all serious and dedicated staff and students. The plan was to get to the end of the island and then run along the final peninsula here, which we would practice doing this as well about once a week. It was about 10 kilometres to the end, past the sunken volcano you can see at the end. And then if the lava was still coming, the plan was to jump off the end of the jetty and swim to the next island. I did try this once. It's about 4 kilometres away. We would all practice this once a year, in fact. But it was made extremely difficult by the fact that it was impossible to swim in a straight line. The last time I tried it, I got quite close to shore, but then discovered these magnificent spotted eagle rays at 90 degrees across my path, which caused me to have to divert completely off course and follow them for quite a period of time. I also saw this wonderful sea turtle here. So, this of course would work fine if the volcano blew, but sadly not if one of these severe tropical cyclones went through and wiped out our island. And there were increasing numbers of these tropical cyclones actually sweeping across the Caribbean island chain where I worked every summer. And indeed, a couple of years ago, sadly, our sister university, Ross University School of Medicine on the island of Dominica, was fairly flattened by one of these cyclones that went south from our island and actually missed us. That's tropical cyclone Irma that I was mentioning before. It missed us, it went to the south, and it wiped out our sister university instead, and much of the island, unfortunately, which meant that the students had to temporarily occupy this converted ferry. This became a floating medical school for a little while, and then were converted to a more permanent facility in Barbados. Now, the National Weather Service in the US has noted that the US appears to be getting hit with major storms with unusual frequency. They're coming in across the Caribbean and hitting the US mainland. They noted that during a recent 12-month period, there were 8 500-year flood events. So these are events that should only occur once every 500 years, and there were 8 of them within a year. Hurricane Irma killed about 134 people, unfortunately, in the US mainland and the Caribbean islands. At the same time, in 2017, more than 1,200 people died across the low-lying regions of southern Asia, being India, Bangladesh, and surrounding regions because of flooding, because of the monsoons that occur during the wet summer period in those locations. And of course, Bangladesh is the most populous region of the world, and many of those people live in very low-lying areas that are very vulnerable to flooding. People who live on some Pacific islands are actually having their islands threatened by sea level rises. If the temperature rise exceeds 1.5 degrees, it's thought that places like the Maldives could become completely flooded and uninhabitable. It's already the case that a combination of high tides, storms, and sea level rises associated with climate change are starting to sweep across low-lying atolls, leaving salty deposits when the waves have receded, which sometimes is rendering the land arid and unable to grow normal feed crops, rendering the land uninhabitable, I should say. So these islands are increasingly threatened by these sea level rises, which are associated with, unfortunately, melting of the glaciers and thermal expansion of the oceans caused by climate change. So all of these extreme weather events are basically telling us that our planet is starting to change. They're early warning signs. And what I want to talk more about in this presentation is the prior history of mass extinction events that have occurred on planet Earth, the current mass extinction event that we're now starting to live through, primary causes of that, the impacts of climate change in particular, the contributions of the livestock sector to climate change, and a word about mitigation strategies for being able to address this. Now, when we look at the fossil record, we can see evidence of 5 mass extinction events in the last 540 years, and these are events in which more than 50% of animal species have died. Prior to this time, animals with hard body parts and hence significant fossilization hadn't evolved, so we're not sure what occurred prior to that, but there have been at least 5 of these events. The oldest was 443 million years ago. It was associated with very rapid glaciation. Sea levels fell by more than 100 meters as the water was essentially sucked up into glaciers. This devastated shallow marine ecosystems, and less than 1 million years later, there was a second wave of extinctions as the ice melted and the sea level rose rapidly. Late Devonian, 360 years ago, another messy, prolonged event, again hitting life in shallow seas very hard, probably due to climate change. The worst one of all was number 3, the Great Dying, about 250 million years ago, when more than 95% of species died, associated with massive volcanic eruptions in Siberia, spewed out vast amounts of gas and dust into the atmosphere, which essentially enabled this sort of gaseous blanket to form around the planet, which does what greenhouse gases do, which is to prevent solar radiation from bouncing off the Earth and back out into space, but rather traps it around the planet, causing planetary heating. 200 million years ago, there was the next one, also linked with a huge outburst of volcanism. And 65 million years ago, the very famous event that killed off the dinosaurs and much else, when an asteroid impact on Mexico probably did the damage. Again, spewing probably vast amounts of dust up into the atmosphere, changing the atmosphere. So many of these are actually associated with atmospheric changes and quite often with things like global warming. We can determine what the normal, so-called natural rate of extinction of species is by examining the fossil record going back in time. And having recently done this, we can now be sure that we are now starting to live through the 6th mass extinction event. Rather than the 9 extinctions of vertebrate species that would expected to have occurred since 1900, conservatively, we've had nearly 470 of these, spread among the different taxonomic groups: mammals, birds, reptiles, amphibians, and fish. And depending on the group, the extinction rates are 10 to 100 times higher than the background rates. So these scientists, Cabalios and colleagues, concluded that the 6th mass extinction is beginning, will grow to rival the last great catastrophe of the past, when the dinosaurs and many other species died out 65 million years ago. And this is expected to occur in as little as 3 human lifetimes, and we are currently living through the first one of those. Now, chillingly, this study actually did not factor in the effects of global warming. It simply considered the major kill mechanisms operating today of habitat loss, predation, and pollution, and it didn't consider global warming and ocean acidification. The authors concluded that we're actually living through one of these brief, rare episodes in Earth's history when biological framework of life is actually dismantled. So, what are the causes of this catastrophic effect on the global biosphere? Well, certainly habitat destruction and deforestation is a primary cause. Livestock production occupies 30% of the Earth's land surface, a really quite staggering amount. And ever-increasing production is a key driver of deforestation, particularly Latin America. Now, the Amazon rainforest is the greatest rainforest area in the world. It's the most biodiverse ecosystem on the planet, and it produces a lot of the oxygen that we all need to breathe, we all depend upon. 70% of previously forested Amazonian land is now occupied by pastures, with feed crops covering a large part of the remainder. Those pastures and feed crops are largely used to grow beef cattle, many of whom end up as being hamburgers in America and other developed nations. So in return for that social benefit, we are losing large parts of the Amazonian rainforest, which, as I said, is the most biodiverse ecosystem on the planet. Professor Philip Limbury is a visiting professor within our Centre for Animal Welfare at the University of Winchester and the author of a couple of key books in this area, including Farmageddon and Dead Zone, Where the Wild Things Were. And in Dead Zone, he essentially travelled to a number of locations in the world to witness the effects of modern farming systems on the local ecosystems. He describes flying in a light aircraft over what used to be hundreds of kilometres of Amazonian rainforest, just observing empty pasture and feed crops rolling on for hundreds of kilometres where there used to be rich biodiverse rainforest. And it's quite tragic to read his description. We're also losing habitat because, of course, of urban sprawl. Certainly, as here in the United Kingdom, we are seeing the encroachment of towns and cities ever increasingly into the surrounding forest and landscape. Obviously, pollution is a major issue. We've got the increasing collapse of the majority of global fisheries worldwide. And of course, there is also the issue of climate change. As Cabalios and colleagues said in their key publication in 2015, the networks of ecosystems and metasystems that comprise life on Earth, in other words, the ecological support systems we all depend on, are deteriorating rapidly, and as a consequence, climate change coupled with the fragmentation of habitats and rapid extinction of species are jointly creating a spiral of feedbacks that are more likely to exacerbate and accelerate the problem. Fragmentation of habitats is an obvious example. When small populations of animals get increasingly cut off from one another, and being from Australia, I could give the example of koalas. There are not many koalas left anyway, and as roads and urban development encroaches into forests in which they used to live, these populations of animals can become cut off from one another, essentially in ecological islands. When populations of animals become small enough, below, for example, approximately 100 individuals, they can end up not having sufficient genetic diversity within them to be able to cope with new challenges that might arise, such as the introduction of a new disease or a random chance event such as a drought that may put the population under a lot of stress in a particular year. This can cause the numbers of successful offspring to decrease in future generations, which decreases the population further. This results in basically an extinction vortex, a spiral downwards into extinction. So, the current geological age is the period in which human activity has become the dominant influence on climate and the environment, has been termed the Anthropocene. You can see the projections on screen of the likely temperature rises by the end of this century, somewhere between about 2 and 5 degrees from those around compared to the year 2000. Currently, the Earth's surface temperature in the year 2019 was almost 1 degree warmer than the average temperature for the entire 20th century. And it's currently rising at around about 0.2 degrees per decade. So that means that in 50 years it would have risen around about another degree. That would be 2 degrees in total. I'll also throw in that 9 of the 10 hottest years in history have actually occurred since the year 2005. Now, we know that when the Earth's temperature rises above 2 degrees and possibly even 1.5 degrees, a bunch of positive feedback mechanisms are triggered. One of those, for example, is the melting of the polar ice cap, which means that the white ice covering that part of the Earth, successfully reflecting solar radiation back into space, becomes replaced with darker oceanic water, which doesn't reflect the light nearly as well, and in fact it absorbs it within the sea, resulting in what you can see there in the second chart as being, the second figure as being a much greater temperature rise over the northern polar region. Another example is the melting of the Siberian permafrost, releasing literally billions of tons of methane gas into the atmosphere. Now, methane gas is a potent greenhouse gas. It's 72 times as effective as carbon dioxide over a 20-year time frame in causing global warming. So as these mechanisms are triggered by the melting of the Siberian tundra, permafrost, and the polar ice caps, it means that global warming accelerates, unfortunately, and it's thought that runaway climate change that will be virtually unstoppable is likely to occur when we have reached around about 2 degrees, and maybe even less, maybe 1.5 degrees above planetary temperatures last century. So we're already about 1 degree above, and we expect to get the extra 1 degree in about another 50 years from now. What is climate change doing to animal species around the world? Well, certainly changing habitats. For example, koalas again, increasing carbon dioxide concentrations in the atmospheres, resulting in eucalyptus leaves becoming toxic to koalas. And these are the only leaves that koalas actually eat. So this is threatening the survival of their species still further, along with habitat fragmentation and disease. You're seeing changes to geographic ranges and migratory habits of animals. Species are moving closer to the poles or climbing higher in the mountains every decades. Some species benefit from climatic changes and spread further, such as bark beetles in the northwestern forests of the USA that are damaging forest habitats that other animal species depend upon. And essentially, the more adaptable species, the greater its survival chances, but sadly, most species do not have sufficient adaptability to cope with the coming changes. These, once again, are mostly my own photos. These, in fact, I think they're entirely my own photos. That's me in the top middle. This is when I went back to Queensland to collect my PhD degree in 2010, and we took a side trip to the outer Great Barrier Reef, to Hardy Reef here. Now, I love snorkeling. As an Australian, I've spent far too much time in the waves, particularly during my grade 10 high school examinations. I was spending far too long body surfing off the coast of Perth where I lived, and it's a miracle that I actually passed anything and came to be here today. But I love coral reefs in particular because they're home to 1 to 3 million fish species, about a quarter of all marine fish species, and they're the most biodiverse marine ecosystems. They're essentially the rainforests of the sea. As you can see, they're particularly beautiful. So I find it particularly tragic to see things like this. Our reefs are increasingly being destroyed around the world. We've already lost 30% of our coral reefs worldwide, and we're on course to lose more than 60% of them by the end of this decade, by the end of 2030. Now, this has been caused by overfishing, pollution, disease, invasive alien species such as the coral-eating crown-of-thorns starfish, but particularly by coral bleaching, by oceanic warming. Most of the global warming that's going on is actually occurring in the oceans, and when that occurs, it actually kills the fragile unicellular algal polyps that reside, the fragile unicellular algae that reside within coral polyps and give coral its distinctive colour. It's thought that the atmospheric carbon dioxide levels of 350 parts per million would not be sufficiently low to prevent the catastrophic loss of coral reefs worldwide. We are now on 411 parts per million as I speak. And to those who were hoping that the loss of air travel following COVID-19 might help this situation, I would say that since I last checked this in July of last year, so just over a year ago, the level has fallen from 414 down to 411 at the moment, so it's dropped by 3 points. And if you look at the long-term trend of atmospheric carbon dioxide levels over nearly the last million years, you can see how virtually insignificant a 3-point drop is. You can see previously when the CO2 level has spiked, we've had periods of interglaciation, so the glaciers have essentially melted, causing the sea levels to rise. And when the CO2 levels have fallen, we've had ice ages, so the sea's essentially been sucked up into glaciers again. Look at where we are now. We are far, far above any of the previous levels of glacial melting in the last million years, and 3 points of difference, unfortunately, is not going to help very much. This, as I mentioned, is one of the sea turtles I saw when I was swimming between our two islands, practicing our evacuation plans in case the volcano blew up. And I'm particularly keen on sea turtles. I saw a lot of them when I was in the Caribbean, and so it particularly upsets me that they are being so badly impacted by climatic changes. The impacts on them are fourfold, really. There are 7 species of sea turtle. The very largest is the leatherback turtle, which is around about the size of a small billiard table and subsists primarily upon soft-bodied jellyfish. Now, these jellyfish are particularly vulnerable to changes in oceanic temperatures and the currents that go along with that. This in turn threatens the leatherback sea turtles. Likewise, many of the other turtles subsist upon the small organisms that frequent sea grass beds and also coral reefs, and are likewise threatened. Sea levels are rising around about 3.5 millimeters a year at the moment in the Caribbean, and tropical storms are coming, as I mentioned, with increasing intensity. Both of these are increasingly threatening to wash out the beaches that many of them use for nesting sites. In the summer, the sand temperatures on the beaches is rising. When it gets to about 35 degrees, you start getting really big mortality of some of the sea turtle species, with very few survivors from those eggs. I've many times stood upon sand on Australian beaches that seems to be about 35 degrees, and perhaps some of you have as well. In that case, you will understand well, I think, how this could be fatal, unfortunately, to sea turtle eggs. And finally, as the sand temperature rises, for those that survive, they are more likely to be born females rather than males. The proportion of males being born every year amongst 3 different sea turtle species has recently varied from about 15 to about 35%, so certainly a long way below 50%. For one of those species, it's estimated that the proportion of males will fall to almost 0 by the end of this century, so that would probably wipe out the species. Because of things like this, 6 out of 7 species of marine turtle are currently rated as vulnerable to critically endangered. Now, the United Nations Intergovernmental Panel on Climate Change has estimated that 1/3 of all species are going to become extinct due to climate change, and have said that contemporary climate change now poses the greatest threat to most animal species since the last mass extinction event, which wiped out the dinosaurs about 65 million years ago. We're also seeing impacts upon human public health because of the changing distribution of animal vectors, so that's insects that spread human disease. We are particularly talking about mosquitoes. Those of you who have companion animals in Europe might be aware that as the climate changes across Europe, the distribution of fleas is starting to migrate northwards every year. Fleas don't normally survive outside in northern Europe over the winter because it's so cold, but as the temperature changes, the northern latitudes at which fleas can survive increases to move north every year. So this is one example of the changing distributions of insects, many of which distribute diseases. Uh, the One Health concept recognizes the overlap between human and animal diseases, and indeed the majority of new and emerging human diseases are now considered to come from animal populations. And the dramatic recent example of COVID-19, we're not quite sure where it came from, but there were strong indications that it came from a live animal market in China, is a dramatic example of this principle. Glacial melting is another effect of climate change, of course. Many of you will have seen before and after historical modern day photos of the distribution of glaciers and the lakes that have begun to replace them in various regions of the world. I myself saw this in 2012 when I was here. In fact, I was this is called the Mer de Glace, the Sea of Ice, which is the largest glacier within the French Alps, and there are, I think, about 30 or 40 of those glaciers, so there's quite a lot of them. Now, the level of the glacier used to be up where this red arrow is. It's about 100 meters higher than where the level of the ice currently is. And I actually skied down this glacier around about that time, and I'll come back to that in a moment. But what I want to draw your attention to now is this circled area here, and you can hardly see it, but there are giant flutes of ice the size of houses in that circled area. And that's me attempting to do a little bit of ice climbing very clumsily when I was on a very simplistic mountaineering course back then. I stayed in a really cheap youth hostel because I had no money. And I met this chap on the right. He was from a Russian mountaineering club, and he was really keen to ski down the Valley Blanche, but it was slightly hazardous. There were people that disappeared down crevasses on the glacier on a regular basis. And so his girlfriend back in Russia had told him that he wasn't allowed to go out there on his own again, and if he did it again, she had threatened to cut off a piece of his anatomy. Clearly, Russian girlfriends are not to be trifled with. And so he befriended me in the youth hostel and asked would I like to go with him so that he could report back that he was not alone. Now, on the left here is a French character. He decided to attach himself to the two of us. The Russian guy didn't really invite him, but he was keen to come down the Valley Blanche without having to pay for a guide, and so he joined us anyway. And the important thing to note here is that myself and the Russian guy are the same height. And I think, in fact, that's probably why the Russian guy chose me and not the French guy initially. And the reason is this: the only way onto the start of the Valley Blanche here is via this very famous northeast ridge of Aiguille de Midi. And if you fall off the ridge and fall to the right, you go about 200 meters and then you fall into crevasses. If you fall off the left side, there's only a short distance to fall, but then it goes completely vertical for about 6,000 feet, and you end up in Chamonix, the town of Chamonix, in the French Alps. And there's no other way to reach the start of the Valley Blanche at this point here. So you have to go down this route, and you have to be tied to somebody. And if you slip and fall, you had better hope that the person behind you throws himself off the other side and is around about the same height and weight as you are. And you can see why the blue guy chose me wearing the green instead of the French guy on the left, who clearly is a different height and weight. Anyway, we somehow managed to make it to the start of this Valley Blanche, or White Valley, and began our ski descent all the way down this glacier. As we did this, we noticed the glacier melting as we went down. There were lots of beautiful blue pools of water appearing all over the glacier. And in fact, here is the route that we skied, and we skied off to the side of the main route because somebody on the left here is actually being rescued from having fallen down one of the crevasses, which were increasingly opening up as the ice bridges melted all over this glacier. when you eventually get to the end, it used to be that up around here where the red arrow is, you would emerge from the ice and you could then get a train all the way back to town, having skied about 17 kilometers and dropped about 3,000 meters in elevation by that stage. But the ice has been melting, and every few years they have to build yet another stairway so that you can finish your ski descent of this glacier and finally reach the stairs. You now have to climb all the way up the cliff, up about 100 meters of steps to get to where they built the train station so you can get the train back. And it's thought that this largest glacier within the French Alps may be completely gone within a single generation. As these glaciers melt worldwide, sea levels rise, and it's thought that the sea levels could rise as much as 80 feet over the coming 3 centuries in the worst case scenarios. This, of course, would fundamentally alter many national geographical boundaries and flood major cities like London, New York, and also Gothenburg. More in the nearer term future, we expect that the melting of the Greenland and the West Antarctic ice sheets, combined with thermal expansion of the oceans, could raise sea levels by up to 6 feet. Now, rises of just half that level are expected to devastate the rice-growing deltas and floodplains of Asia, on which hundreds of millions of people depend for food. At the same time, the Himalayan and Tibetan glaciers are melting. These actually sustain the major rivers of India and China, so the Indus and the Ganges and so on, during the dry season, and also the grain irrigation systems that depend on these rivers. Now, the vast populations dependent on these glaciers make this melting the greatest threat to food security ever faced by humanity. That's the scale of the problem that this is likely to cause just to human beings. On top of that, we've got some other problems happening. The human population has actually gone up since this chart was prepared. It's currently about 7.8 billion people, and we are on target to reach 10 billion people by 2050 and possibly 11 at a peak by 2100. Now, on top of the rise in human population worldwide, we're also seeing a change in how people live. There are around about 3 billion developing world consumers in places like China, for example, that are rapidly changing their lifestyles as they seek to emulate what they see as being the affluent and desirable lifestyles of people in wealthy westernized nations. This means a much greater consumption of grain, actually. Grain consumption per person varies from as little as 200 kilograms per person per year in places like India, up to a maximum of about 800 kilograms per person per year in places like the US and Canada, where people consume most of that grain indirectly in the form of beef, pork, chicken, eggs and milk, because the grain is then fed to those food animals who are then consumed themselves. During that process, most of the food energy is lost because of the inefficiencies when you convert one form of energy to another. In India, they're forced to eat most of the grain directly because there's very little to spare for inefficient conversion into animal products. So worldwide, the proportion of people that are adopting much more highly consumptive lifestyles that require a whole lot more grain is rising substantially. Around 3 billion people a year are rapidly changing their lifestyles, and the human population is increasing overall. On top of this, we're getting threats to the global supplies of grain from crop-destroying climatic events such as droughts and floods, and also temperature rises. With every 1 degree temperature rise, the yield of crops like wheat, rice and soya drops by about 10%. And so because of these factors, we've seen the prices of staples such as sugar, corn, soybeans and others increasingly rise over the years. Now when prices go up, this affects the people least able to pay for these crops. And a result of these factors, we've seen the human population suffering from hunger and malnutrition rise from about 825 million in the 1990s to over 1 billion people and still climbing. So there's a major food injustice issue here, which is being affected by our rising population, the change in lifestyles of those who can afford to change, and also climatic changes decreasing crop yields. Now, all forms of transportation combined worldwide have been estimated to produce around about 13.5% of greenhouse gases. And we often hear about how we should be changing our transportation habits, flying less, driving less, and so on. In 2006, however, this seminal report came out of the United Nations Food and Agriculture Organization called Livestock's Long Shadow, which estimated that 14.5% of worldwide greenhouse gases were attributable to livestock farming. So that's more than was produced by the entire transport sector combined. We've heard so much about why we shouldn't fly as often as we do, but we've heard so little about how we should change our diets. This contribution of the livestock sector is because it contributes around about 9% of all human-generated carbon dioxide, and that's mainly from clearing forests to make way for pastures and feed crops to feed to animals. Around about 30% of the Earth's land surface is currently consumed by animal agriculture. Ruminant animals, those cows, sheep and goats with their four-chambered stomachs filled with bacteria capable of breaking down grass with its very solid cell walls and producing soluble fatty acids that can be consumed by animals to burn for energy and produce proteins. Those bacteria actually also produce methane as a side effect. The livestock sector produces about 37% of all human-generated methane on the planet. And methane, unfortunately, has a global warming potential that is about 72 times as severe as carbon dioxide over a 20-year time frame. And then the manure that livestock animals produce is enormous. Concentrated animal feeding operations, feedlots in the US can produce as much manure as small to medium-sized US cities, but without any sewage treatment system. So this manure produces vast amounts of nitrous oxides. These nitrous oxides are a staggering 296 times more damaging than carbon dioxide is as a greenhouse gas. And the livestock sector produces nearly 2/3 of all human-generated nitrous oxides. It also produces about the same amount of ammonia, which goes on to acidify ecosystems and cause acid rain. Now that was in 2006. The current best estimate of the amount of greenhouse gases produced by the livestock sector is around about 16% of all human-generated greenhouse gases. What are the strategies for decreasing impacts? Well, there are some things that we could do. We could reduce methane emissions by feeding higher quality diets involving more grain and more fats within the diet. The trouble is, this means growing grain and feeding them to livestock, which is an inefficient food conversion process, resulting in less food available for overall, higher prices for grain, people less able to afford grain being less able to buy it, and farmers in many parts of the world would not be able to afford this either. Managing manure, such as chilling the manure. If you chill manure slurry to below 10 degrees, you can cut the nitrous oxide emissions by 20%. However, this is very expensive to do. You can put giant caps over the top of slurry lagoons in order to capture the biogas emissions from it. This is also expensive to do, and these technologies are simply not available to many livestock farmers around the world. We can also try to decrease deforestation, encourage carbon sequestration through improved pastoral management. An example would be the silvopastoral systems that involve trees being planted within paddocks here and there to provide some shelter to livestock as well. However, remembering that 30% of the Earth's land surface is actually taken up by the livestock sector, clearly we're going to need a lot more, I think, than a few trees planted throughout pastures to make a significant difference to this problem. Because of both the increasing global population and also the change in our lifestyles to become more consumptive overall, global meat and dairy consumption is expected to double by 2050. Accordingly, as Steinfeld and colleagues said when they produced that Livestock's Long Shadow report in 2006, the environmental impact per unit of livestock product must be cut by half just to avoid increasing the damage beyond its current level. So all of these mitigation strategies are quite incapable of cutting the environmental impact by half on a planetary-wide basis. Accordingly, when Dr. Rajendra Pachauri, the head of the Intergovernmental Panel on Climate Change, said when receiving the Nobel Peace Prize for its work in 2007, he implored the world to please eat less meat, and he's since repeated and strengthened that call. We really must also add to that a call to eat less dairy and less other livestock products as well, because of the environmental and animal welfare damage that they also cause. So as I've said in my writings, the solution to our problems could hardly be simpler. This is the one major change that we can make on a widespread basis that doesn't require the development of any new technologies. It doesn't require us to alter the transportation that we used to and from work. It doesn't require us to alter the way in which we run our non-livestock industries and societies. So it's something we can do virtually immediately and would have a major impact, certainly for climate change, but also for animal welfare and public health. But it's the wisdom required to implement these changes that appears beyond our collective reach. Unfortunately, there are significant barriers to cultural change. We've seen the rise of anti-scientific denialism spearheaded by champions such as this in recent times. Thank goodness for the recent election result. But there are signs of hope around the world as individuals and cities do what governmental leaders fail to do. I'm virtually done with my presentation, and this is a point where I would normally ask for questions, but on this occasion I'd like instead to ask, what will you all do about this issue in the short-term future and over the span of your lifetimes as well? Effective altruism is the philosophy that we should make choices that maximize the amount of good that we do and minimize the amount of harm that we do to others. And it asks us to think about the range of issues that we could choose to focus on and think about how big they are in terms of problems, how solvable they are, whether other people are already working on them, how neglected they are, and about our own personal skill set and fit. And having considered those things, to then choose the issues that we work on accordingly. It makes a lot more sense to work on some than on others. Now, as a veterinarian, in my last couple of slides, I wanted to flag up that I'm particularly interested in the environmental impact of food consumption by cats and dogs. There have been a couple of studies just in recent years demonstrating that this is actually quite significant. Ocken 27 demonstrated that the environmental impact of pet food in the US is 25 to 30% of the impact of the entire livestock sector in terms of land use, water use, fossil fuels, pesticides and fertilizers, and it also contributes a significant amount of greenhouse gases. So what I'm doing this year is actually some research into how healthy cats and dogs can be on different diets, plant-based and other diets, for example, and how their well-being might be affected. Next year, I want to look at what would be the impacts on environmental sustainability metrics if we were to switch partly or fully to plant-based or other alternate pet foods for cats and dogs, and I'd love to come back and talk to you another time about these study results in due course. going to close really with this study that's just come out a couple of weeks ago, and these seem to come out on a monthly basis now, which noted that, this was in Science magazine, in order to have any hope of meeting the central goal of the Paris Climate Agreement of 2015, which is to limit global warming to 2 degrees or less, which is necessary to prevent runaway climate change, our carbon emissions have to be reduced considerably, including those coming from agriculture. Even if fossil fuel emissions were eliminated completely, emissions from the global food system alone would make it impossible to limit warming to 1.5 degrees and difficult to realise the 2-degree target. So we must change our food system. I'm going to finish with this slide from ProVeg. We are in the most decisive moment of human history on Earth. Food will be the make or break it for our prosperity and for the sustainability of coming generations. So, having said all that, what will you do in the short-term future and over the course of the time that you've been given here on planet Earth? It's hard to think of any greater tragedy, I think, than the wholesale loss of the other living species with whom we share our planet. And I think that tragedy is compounded by the fact that it's very much one of our own making. So please do all you can to help decrease not only your own impacts upon the Earth, but also the impacts of wider society, depending upon your skill set and what you can achieve during the time you have upon the Earth. Thank you so much.